you need to find page 65 in your math workbook and rip it out. Get your name and number on both sides. Pause the video once you've done that, and then you can continue with me. Well, after going through all of those steps and all of those practice and making a few mistakes, it's so good to practice so that we can work on this. So we're going to work on page 65 together. We might not be doing all of it, so make sure you're paying close attention. Okay? Here we go. Number 1. A number changed to 12.6 after it was rounded. So that was the final answer they got. To what place was the number rounded? Explain how you know. Well, remember, you have to always end in the place value they ask for. So they ended in the tenths. Explain how you know. So it was rounded to the tenths. Period. I know this because it ended in the tenths place. Period. So it's pretty great. The number 2 is going to be something similar to that, so we're going to skip that. Number 3, what place value would this one have been rounded to? The ones place, because it ended in the ones place. So that's pretty easy on number 2 and 3. 4 through 21 right now is just quick practice. So we're just going to do a couple in each section. Okay? Number 4, round to the nearest whole number. Ooh, that's a good one for Miss Fisher. The wholes is the ones place. So you just draw a little arrow. Make sure you underline. That's going to be important. You have to show the underline and the arrow. The 1 looks over to the 7, and the 7 tells the 1, hey, I'm a 7. I'm the boss. 5 or more, raise the score. So you got to change to a 2. Everything in front of it stays the same. Everything behind it disappears. Did you end in the whole numbers? And you did it correctly. Let's do number 7. Round to the nearest whole number. Ooh, is 0 a number? Yes. You still have to underline that. Underline the 0. The 0 looks over at the 9. The 9 tells the 0, hey, raise the score. So 0.97 rounds to 1. Let's do number 9. Which digit is in the ones place? That 9. Looks over at the 0. The 0 tells the 9, hey, I'm just a 0. Let it rest. You get to just be a 9. Pretty great, right? Okay, let's skip to number 10. Now we're rounding to the nearest hundredths. Which of these digits is in the hundredths on number 10? Is it the 4? No. The 0? No, that's the 10. 5. And the 5 looks over at the 1. The 1 says to the 5, 5 or more, raise the score. 4 or less, let it rest. So the 5 gets to rest. Gets to stay the same. Everything in front of it stays. Even the decimal and the whole. Everything behind it leaves. Did I end in the hundredths? Yep. So I know I did that one correctly. Let's do number 14. Number 14. Round to the nearest hundredth. So we underline the hundredths place. See, you really have to know your place values. The 1 looks over at this 5. 5 or more, raise that score. So that 1 changes to a 2. Everything in front of it stays the same. Everything behind it disappears. 75.12. I think the hardest one they're going to try and give you is number 15 right here. We can do this. Round to the nearest hundredth. Which of these digits is in the hundredths? It's the middle 9 right there. Lots of 9s. We got this. The 9 looks over here. 5 or more. Raise that score. That 9 changes to a what? A 10. Put the 0. Carry the 1. 1 plus 9? 0. Carry the 1. You have the decimal still. 1 plus 8? 9. And everything else stays the same. So that one is 4,259. But I need to end in the hundredth, so I keep the 0.00. Final answer. It's pretty great. Let's skip to the next section. Round to the nearest tenth. Number 16. We need a digit in the tenths place. Here's the tens, but I need tenths. Remember, it's the one right after the decimal. So I underline the 1. I look over at the 6. The 6 tells the 1 to raise the score. So the 1 changes to a 2. I have the decimal in front of it, and I have 51 still. I end in the tenths. Let's do number 17. 8.55, which of those is in the tenths place? The first 5. Looks over at that 5. That 5 tells that 5 to raise the score. Everything in front stays the same. 8.6. Let's try, let's see. Number 21. Tenths, underline the 1. Look to the 8. The 8 tells the 1, raise the score. Changes to 0.2, and the 0 is out in front. I know we're cruising through these, but it's because you should know how to do this pretty quickly. Turn to page 66. Here is where I wanted to spend the majority of this time, with estimating sums and differences. You're going to get this on your assignment, and you're going to need to know that estimating means rounding. When you estimate something, you use rounding. So we're going to write that. Use rounding. Okay? You use rounding. So let's just take a look at number 24. If I'm using rounding and I'm talking about money, the easiest thing to do in this situation is to round to the nearest dollar. Okay? Estimating to the nearest dollar. So the ones place. So I look at the 3. I look at the 5. The 5 tells the 3 to what? Raise the score. Right? So it's about $4. Because I would raise that to a 4, everything else would go away. Now look at the 1. The 1 looks over at the 5. The 5 tells the 1, hey, raise the score. The 1 changes to a 2. So my estimate should be about $2. All I'm doing here is estimating. I am not even finding the actual answer yet. I'm just estimating. So that's pretty cool. Let's do another money one. Let's do number 22. $17.25. I think the ones place still with money is going to be the best way to do this. Look over at the tenths. The 2 tells the 7. Let it rest. Gets to say is 17. And technically there would be a decimal, but remember I'm just going to the ones, so I can just leave it. And I'm subtracting. And look at the 1179. The 1 looks over at the 7. 7 tells the 1, hey, you should probably bump that up. So that bumps up to a 12. So my estimate on this, 17 minus 12, is about $5. You could put 5.00 if you wanted. You could just do 5 with a dollar sign. It doesn't matter. Let's try one that's not money. Number 26. What do you think, which place value do you think it would be best to round this one to? Maybe the ones? Maybe the tenths? Yeah. I think it might be good to round to the, you could round to the hundredths if you really wanted, but let's round maybe to the tenths. Okay? The 0.7 looks over at the 1. 1 tells the 7, hey, you got to stay the same. So everything else stays the same in front of it. 0.7 minus. Now I underline the 6. You got to underline the same place value when you're estimating. Whichever place value you chose, you have to do it to both numbers. Okay? The 6 looks over at the 9. The 9 tells the 6, hey, you got to bump up. You got to raise the score to 7. So everything in front stays the same. Take a look at that. 0.7 minus 0.7 is 0. That's my estimate. So I'm telling you, when I get done subtracting these, it's going to pretty much be like I have nothing. It's going to be such a small decimal that it's close to 0. That's pretty cool. That is totally reasonable and makes sense. Okay? The ones we really want to spend time on is numbers 28, 29, and 30. Number 28. Please pull out one of the colors we were using today. Rick thinks the total cost of an $89.95 soccer goal and a $9.99 soccer ball is $90.94. Write your estimate of the total cost, then write the exact cost. So we're going to estimate it first. Okay? $89.95. Let's round to the nearest ones. That 9 looks over to that 9. The 9 tells the 9 to bump up to a 10. So you leave a 0 and not a 1 there, and 8 and 1 make 9. So it's 90.00. Okay? So one of my estimates is $90, 90, and I'm going to add it to the cost of the soccer ball. You should just know, without using rounding, what $9.99 is really close to. It's close to $10. You should just know that. So my estimate is going to be whatever 90 plus 10 is, which is $100. My estimate, $100. And now it wants me to find the exact cost. How do I find the exact cost? I stack it up. Do you know the button man, the button man, the button man? Do you know the button man? He lines the decimals up. Look, they have to be lined up. You don't need a zero the hero, but you're adding these. So 5 plus 9 is 14. That's 18 plus another one is 19. Carry. Don't forget the decimal. Button it up. That's 18 plus 1 is 19. Take a look. My actual cost is $99.94. Was Rick's answer reasonable? So Rick was thinking the total was going to be $90.94. Well, did he have a reasonable answer? My answer there would be no, he did not. It's not reasonable because he's like almost $10 off. So it's almost like he just thought that was like $1 versus it was, $10. So was Rick's answer reasonable? No. It was not reasonable. And you can explain why or why not. You can say reasonable because it wasn't close to the actual cost. Or you can say because when I rounded, I got $100. You can say anything there to explain that. But in that situation, it was not reasonable. Okay? All right. Number 29. Marty has 20.15 meters of red and blue fabric. Of that, 9.28, so 20.15 is the total, and it's mixed red and blue. 9.28 of it is red. The rest is blue. So that means I'm going to be doing what? Subtraction. Marty calculated that she has 10.87 meters of blue fabric. Is it reasonable? Explain why or why not. So in order to know whether it's reasonable, we're just going to use rounding and see, is that close to her answer? 10.87. Okay? Let's do this. Let's go 20, let's stack them up. 0.15. Actually, we'll line it up like this, moving left to right. Minus 9.28, just so that we can use rounding. Okay? Let's round, let's see. Let's round to the nearest ones, should we? So we'll underline the ones here and the ones there. The 0 looks over at the 1. The 1 tells the 0 to stay the same. Okay? And the 9 looks over at the 2. The 2 tells the 9 to stay the same. Everything else disappears. So what is 20 minus 9? It's 11. What did Marty actually get? 10.87. Is 10.87 close to 11? Yes. Those are close. So I'm just going to go like this. I would say, is Marty's answer reasonable? Yes. Exclamation point. It is reasonable because $10.87 and my estimate of 11 are close. Okay, they are close. All right, and the next one. In a video racing game, Lee completed 1 lap in 47.32 seconds. Donna completed 1 lap in 45.41 seconds. How many seconds faster was Donna's lap? They want an estimate and an exact answer. So let's estimate by writing them in a sentence. 47.32 minus 45.41, because you're looking for faster, so it is subtraction. Let's go ahead and round to the nearest ones. So here we go. How many seconds faster? So yeah, the ones place. The 7 looks to the 3. The 3 tells the 7, stay the same. So it's 47. The 5 is in the ones, and it looks over to the 4. The 4 tells the 5, stay the same. So 45 minus 47, my answer should be close to 2 seconds. So my estimate is going to be 2 seconds. Let's find the exact answer. So this is where you have to stack them up. 47.32 minus 45.41. 2 minus 1. 3 minus 4, can't do it. Gotta borrow. 13 minus 4 is 9. Decimal. 6 minus 5 is 1. And then nothing. The exact answer is 1.91 seconds. So is your exact answer reasonable? Yes. And I'll just say 1.91 is very close to 2 seconds. Smiley face. Pretty great. That is all you have to do on these practice pages, okay? You can take this. We're not going to be cutting this one, so I want you to make sure your name and number's on it and that you've done all the problems we did together. You do not have to do anything else. Turn this into the math basket and make sure that you pick up your assignment. When you pick up your assignment, or if you already have it, it's going to look like this. Make sure you're paying attention to the place value it asks for. Make sure you use your journal if you need help with how to do these, okay? But look at numbers 10, 11, 12. If you want to pull yours out, so pause the video and go get it, or pull this out, we can do them together really quickly. It says estimate each sum or difference. So it's pretty easy. $46.78. Let's just go ahead and round to the nearest ones. Okay, on both of them. So 46.7. You look over at the 0.7. The 7 tells the 6, hey, raise your score to 47. The 8 looks over at the 5. The 5 tells the 8, hey, raise your score to 19. 47 minus 19. It's almost like doing minus 20. So 47 minus 20 would be 27. But it only took away 19. So it would be 28. And it has the dollar sign. That's my estimate on that one. Number 11, estimate each sum or difference. I would go to the ones place. The 12 looks to the 3. The 3 tells the 2, hey, stay the same. So it's 12. Ones place. 4 looks to the 7. 7 tells the 4, oh, you got to raise the score. So 12 plus 5 is close to 17. You have to show these underlines and the arrows. Okay, that is going to be a rule on all of rounding. Let's round again to the ones. The 9 looks at the 5. The 5 tells the 9, oh, change to a 10. The 3 looks to the 0. The 0 tells the 3, stay the same. And 10 plus 3 is 13. So it's really not so bad, okay? Number 13 is going to be a little challenging, but I don't want to help you with it. I want to see how you do with this. Please read it slowly and go over it and make sure you're paying attention. And just remember that we can always add zeros after the decimals. So for example, if I have a 0.7, it could also be 0.700, right? It could also be 0.7,000. It could go on and on and on. So that's going to be important as you read this problem. On number 16, you're going to just look and see about the cost he wants and that if $20 is going to be enough. But they want you to use estimation to decide if it's reasonable. Okay, so it doesn't really want you to solve it. It only wants you to use estimation. That's it. You can do this. And then on the remembering side, it's 2 quick story problems. You're going to look for amounts of liquid on this one. So this guy is pouring orange juice from a measuring cup into a larger container, and then he pours some of it back in. So how much orange juice remains in the measuring cup? So he's pouring this much into a measuring cup, and then he takes that much out of it. So this is going to be a subtraction problem. This one says in all. So that's going to be an addition problem, right? So in this situation, you're going to have denominators that are the same. So good luck when you stack those up. All of them are like that. You know how to do 3, 4, and 5. You're going to need a 0 the hero on number 4 and number 5 down there. 6 and 7, I love the distributive property. Use the distributive property. Remember, find the identical factor. So in this case, it's 5. Pull it out. Add the other 2. What's 600 plus 400? Excuse me. It's 1,000. Final answer, 5,000. And you can do number 17. Don't worry about stretch your thinking. Thanks for hanging in there today. That is all of the videos today. Have a great time.